Hi guys, in this video I am going to talk about how do we charge something, right? Now this may sound like a kind of silly question, like what do you mean how do you charge something, right? We're talking about obviously electrostatic charge. Now look at any object around you. So I can take this pen, you can take human body, you can take the chair you're sitting on, anything, right? It consists of molecules and atoms, and if you take any atom, right, an atom would have a positively charged nucleus, and there would be lots of electrons, right, which are moving around the nucleus, right? Now they are obviously not moving around in circles actually, but just trying to give you some idea, right? Okay. Now when we say that how do we charge something, you might ask like what does it mean? It's already charged. But here what's the key thing? The key thing is the total positive charge and total negative charge is always going to be equal. Okay. So if I have, let's say, one atom where we have, let's say, 30 protons, it will have 30 electrons. Most of the time, not always, most of the time, right? And then even though there is a lot of charge, the total charge, right? Total charge is 0. Total charge, right, would be 0. Okay. So now when we say charge something, so let us say I have a glass rod here, right, and I want to charge this, right. Now we have discussed that if I rub it with, let's say, silk cloth, right, very, very hard, right, very quickly, then what will happen? Then what happens is, they attract each other, right. So what does it mean? What it means is that if I look at any molecule, let's say I zoom into one molecule here, or one atom, let's say, one atom has got a nucleus and electrons around this, right. Now what has happened is when we rub this, right, for some reason the electron jumped from the glass to the silk. So this was my silk cloth. I'll use a different color for that. So let's say this was my silk cloth, right? What happened? This electron went from here to here, right? When that happens, right, what happens? When that happens, now here, before this there were, let us say, there were n electrons, right, and there are n positive charges in the nucleus, which means there are n protons, right? There are n protons, right? So n and n, plus and minus, net charge is 0. Now when one of them has jumped, what has happened? Now we still have n protons, but now the number of electrons, now we still have n protons, but number of electrons is n minus 1, right? Earlier the total charge was, how much was total charge? The total charge was plus n, and let us say one charge, I'm just going to call it E, one charge of an electron, which is what? Which is 1.6 into 10 to the power minus 19 coulombs, right? That is the charge of each electron and each proton in magnitude, right? So the total charge would have been plus n into E minus n into E, which would be equal to 0 initially, this state, right? Let's call the scenario A and let us call the scenario B. So in scenario A, you would have plus Ne minus Ne, 0. In scenario B, what happens? Now you have, scenario B, you have, for this particular, for the glass, right, you have plus Ne minus n minus 1 into E, right? Now this is no longer 0. Why? Because now this would be plus Ne minus Ne, and we'll have plus E, right? So this is now equal to plus E, right? So this is no longer 0. So now this rod would become positively charged, right? So this is how, this is one way to transfer charge, and this process of charging. So now we can say that the glass rod is charged and this is also charged, and here the charge is plus E and here the charge would be minus E, right? And this method of charging, we call it, so we say this is charging by friction, Okay. What else? How else could we charge something? Now, let us say I have one, say, metal sphere. So let's say I have a metal sphere, right? And I've put some charge here, right? So there is some positive charge here, right? What does positive charge mean? Just think about it. It means that there's somehow some electrons have been taken away by some mechanism. Doesn't matter. Okay. Now I bring another conducting sphere, right? And I touch both of them. You bring and then they make contact, right? Then they make contact. So let's say now this one, it comes here and now it makes contact. Now what will happen? When it makes contact, now think about it, right? So here the number of electrons is less than number of negative charges is less than number of positive charges, right? So as a result, and here the number, so there are electrons and protons here as well. The positive negative charges here are balanced. So the positive and negative charges, they are balanced here, right? But here, because there are more positive charges, this sphere it would pull the electrons because there are more positive charges. So this electron, right, it will get pulled here, right? When this electron gets pulled here, what will happen? There will be some pause. So now this particular plus charge is now left alone, right? So now as a result, what will happen is when electron goes here, the charge here will go down and charge here. So the plus charge will go down and here plus charge would get created, right? So initially it is plus and this is 0, and at the end of it you would have fewer number of plus charges here, but this one also would have some positive charge, right? So now the charge is getting distributed, and this method of touching two objects, right, and then charge flowing from one to the other, we call it. So first was by friction, second is by conduction, right? Conduction, and here we take, in this case we have taken two metal objects and touched each other, and the charge flew from one to the other. Okay. There is a third way of charging which is called induction. Now, what is that? This is actually interesting, right? So how does induction work? Let me explain this. Right? Induction. So we talked about friction, we talked about conduction, now let's talk about induction. So now let's say, similar scenario, I have, let us say, one sphere here, metal sphere, and it's got, let's say, it's got say plus charge. Right? And I have another sphere here, right? And this sphere has no charge. Right? When I bring them, and both are conductors, right? Both are metallic conductors, I bring them closer, what will happen? Now because this positively charge is going to pull the electrons towards itself, right? And the special thing about a conductor is that there are many electrons, not all of them, there are many electrons which are free to move around. So let's say there is one positive, I'm just saying there's one positive nucleus and there are some electrons. This electron is free, this electron can actually walk around, can kind of move around freely, right? So when you bring them closer, what will happen? They are not in contact, but still there is a pull. So this electron, let's say this electron moves here. Now minus. So electrons are pulled here, and as a result there will be plus charge left on the opposite side, right? Because electrons would try to come as close as possible. So let's say you're standing let's say in a balcony, and something happens on the road, and you're curious what happened. So all of you will go and like bend over the balcony to see what happened, right? So like that, electrons will come to the edge, and as a result on the other side there will be plus charge left. So we have minus here, plus here. So now we have a separation of charges with, now the total charge is still 0, but there is a distance between them. Now if I were to, let us say, connect this to let us say ground, right, to earth, right? Now what will happen? Now here electrons are being pulled, right? So now what will this charge do? It can actually pull some electrons from the ground. So effectively positive charge is going down and there will be negative charges here, right? So the point is this charge is pulling electrons from here. So now there is a pull to get more electrons away. There's a force acting which is bringing electrons. So some electrons from earth, right, would jump up and go here, right? This electron jumps and will go here. So there will be some electrons which will go from earth to this. Earlier, remember, the total, while we had negative and positive, the total was 0, but now some charge from here has jumped here, right? Now look at this particular sphere, what has happened? Now this has got some excess negative charge, because from earth they have been pulled up here. Now if I remove this object, you'll find that this sphere now has got some negative charge left, right? So this process, when we take it close, right, take a charged object close, it will pull electrons, right, and there is separation. So this is called charging by induction. Charging by induction. Right? So these are the ways in which we can charge an object. Thank you.